So if you want a red card, a red card, sorry. If you want a red card, you're gonna be all these red cards here selected, plus this one as well selected. How many cards so far? 26. Very good. So now the problem is the queen here. We selected already two queens. So you don't need to add them again. 26 plus 4, that will be wrong. Does it make sense? So what you need to add another queen, which is this one, and another queen. So you add only two queens. Two of the four, they were already selected within the red cards, right? And the other two queens, they are the black queens, basically. So in total, how many cards are there? So you're gonna be 26 plus 2 divided by 52, right? So that's your probability you're looking for. So the probability here is gonna be 28 divided by 52. Please use the calculator to reduce this or get it as a fraction, right? You got it? So if you reduce it, what you're gonna get? 7/13. Very good. Okay, so let's see the choices here. So first of all, we have 6 possible colors, right? So we have 6 choices here. Times. Now, next, what we got? With or without air conditioner. How many choices? 2. So multiply by 2. And then, with or without heated seat. How many choices? 2 more. And then, with or without lock brake. That's another 2 more. With or without power window. That's another 2 more. With or without CD player. I don't know if you know what is a CD player, guys. All right. There are no more CD players. But anyway, you got it? Yes? Do we have any more choices? No. So how many choices are possible here? Just multiply everything together, right? Thank you. 192. We good? So 22, they are asking how many different 4-letter radio station call letters can be made. All right, so 4 letters code. We good? Now, what they are saying here, if the first letter can be K or W. So first letter, how many choices here for the first letter? Only 2. Very good. And then they say repetition are allowed, but the call letter cannot end with an O. So they made a restriction on the last one, right? Cannot end with the O. So how many letters left? 25. There are 26 letters. On here there are only 25 choices left, right? Now, since we are allowed to repeat the letters. So how many choices on the second and the third? 26 and 26. Very good. We good? So you just multiply them, right? So just multiply these numbers together, whatever numbers come up. Anybody got it? $33800. Thank you. Okay, what you're gonna do here is very similar to Google, right? So okay, if all the letters they were different, means here this is G1, this is G2, this is O1, this is O2, right? They are all different, correct? If they were all different, how many permutations do we have? Number of permutation, you're going to be, you shuffle them around. That's going to be 1, 2, 3, 4, 5, 6. 6 factorial. That's the number of permutations. However, because we don't distinguish between the two O's here, all right, we don't distinguish which one comes first if I take away the 1 and 2 here. All right, so if they are O and O only. So what I'm going to do, I'm going to divide by 2 factorial. That's the number of permutation you can do. You can flip the O and O. You see, it doesn't matter which one happened here first, the O here and O here. If you flip them around, it's still Google, still the same letter, same word, right? So that is taking away one of the permutations. Make sense? So we divide by 2 factorial. And we have that issue again happening between the G and G as well, right? So since you cannot distinguish between G and G, they are the same. We don't have G1 and G2. So you can always permutate between both of them and the word is the same. All right, it's pronounced with Google, the same thing, right? So that's you can divide by 2 factorial again. Now, for Tennessee, how many letters are there? 9. So that's going to be 9 factorial. And then how many repetitions do you have there? Does the T repeat? No. The E repeats, right? How many repetitions are there for the E? 4, right? So you're going to divide by 4 factorial. That's how many shuffling you can do the E's between each other for each letter. And then, is there any other repetition? The N and N, right? So you can divide by 2 factorial again. Is there any other repetition? There is the S and S, right? So I can divide again by 2 factorial again. And again, do you know how to do this? You need to plug it into the calculator. If you are confused about how to do this, please put a parentheses. All right. If you see a numerator or denominator has more than one term, put the parentheses up on it, right? We good? Anybody got the answer, guys? Thank you. 3780. So this is 25, right? We are all set? You got it? So the formula, what is the formula here? N factorial divided by, yeah, you can put K or N1 factorial, whatever you want, right? So N1 factorial here, N2 factorial, N3 factorial, and you keep going, right, until you finish all the repetition. Let me see. I don't have a calculator. Okay, we have 12 members in 26, right? And we must select chairperson, secretary, and treasurer, right? How many different possibilities? So here what you want to ask, is it the order important or not? What do you think? The order, is it important or not? Why? Very good. Because they specifically say, I want a chairperson, a secretary, and the treasurer, right? Obviously, the secretary cannot switch with the chairperson. Make sense? So it does matter who's first, who's second, who's third, right? So now, then if the order is important, is it a permutation or combination? Very good, permutation. So that's all what you need to know. This is a permutation 12-3 then. All right? And of course, you're going to use the calculator. So use your calculator and figure out this permutation. So this is basically 12 times 11 times 10. So you're going to be 1, 3, 2, 0. 1320. We good? Okay, so we have a total of 20 boys here and 10 girls, right? And what we want to do, we want to select 3 of each, right? 3 boys and 3 girls, right? So is it the order important or not? Order not important. Permutation versus combination then. Combination. So this is combination 20, comma 3. Since there is an and here, we're going to multiply it by combination. From 10, we can select 3 again. All right. Again, please use the calculator to do this. You don't want to risk it. Let me know if you get the answer, please. All right, so what is the combination 20, 20, 23? Basically, you start from 20, multiply 19, multiply 18, right? You come backward and divide by 3 times 2 times 1. The same thing here, 10, count backward and divide by 3 times 2 times 1, right? That's basically if you don't know, if your calculator doesn't take combinations or whatever it is. Luckily, your combination works. So what's it going to be in the end? Okay, so 136,800. All right. Thank you. Everybody okay with this? Use your calculator, please. 38. Every time you have the odds in favor, the odds against, please draw your Venn diagram. All right, it's really simple with the Venn diagram. So this is my Venn diagram. I have a circle. What we are looking for the odds in favor of what? A happening, right? So how many A's do we have here? 1, 2, 3. There are 3 A's. How many outside of the A? 5 left, right? And what they are looking for? Find the odds, right? So the odds here in favor. The odds in favor, they are 3 to 5, right? What the probability of A here, by the way? So the answer is 3 to 5, right? But what the probability? 3 over 8. The probability is whatever inside that circle divided by the whole box. You got it? So there are 8 elements. So now let's get us to the second problem. So the second problem here, suppose that probability of a female living in a particular country developed some type of disease, whatever it is, all right, in her life is about 1 to 7. So now, again, what I'm supposed to do, the Venn diagram, this is the circle of the disease, right? And 1 to 7, so what's it going to be? The probability, they gave us probability. So 1 is going to be inside the circle, and what else outside? 6, very good. So it must be the sum equal to 7, right? Find the odds in favor and against having the disease, right? So the odds here in favor and the odds against, right? So the odds in favor would be 1 to 6. The odds against would be 6 to 1. Oh, you got it? And that's it. For question number 4, they are asking about the expected value. The expected value will have a formula for it. So E of x is equal to x1 times p of x1 plus x2 times p of x2 and so forth, right? Make sense? So this, if I'm going to do it by hand, it's going to be the x's are this are the x's, right? The probabilities are this, the corresponding probability. So this is going to be 2 times 0.4 plus 3 times 0.2 plus 4 times 0.1 plus 5 times 0.3. So this is 0.8, this is 0.6, this is 0.4, and this is 1.5. And I think if you add them all up, 3.4. Are we okay? So that's how you do it by hand, right? Now we're going to do it with the calculator, right? So hang in there. Okay, so in order to solve the expected values without the formula that we just did it in the beginning, by the way, 3.3 it was, right? Not 3.4. But anyways, you need to create your probability distribution table, or it's called frequency distribution table, either with the frequency or probability. Make sense? Easier with the frequencies. So for 41, question number 41 here, what are my variables? It's a dollar sign, right? Okay, so that's going to be your x. And here is going to be the frequency, right? So what are the values of the x? We are in 41, guys. You are winning $76, so $76 winning. Or you end up losing $9, minus 9, right? Make sense? What is the frequency for $76? Is 1 out of 20, right? So you can put just 1 there. What is the frequency of losing? 19 over 20, right? So you just put 19 there. And this is the table that you're going to plug it into your calculator, right? Make sense? And please use the calculator. We care about the answer only. All right. So, hang in there for the calculator. Okay, number 42. What's going to be your distribution table, guys? The x. What are the x's? Anybody can get the x's? How much can you lose? Can you lose anything here? There is only one price of $1,000. Only one price of $500. How many prices of $100? 8 of them. All right. So, how much can you lose any amount here, or only winners? Okay, guys, participate. Come on. You can lose, right? How much can you lose? Nope. $4. That's the maximum you can lose. $4. If you play, you lose $4, right? So the frequency, how many of them you're gonna lose $4? No. Remember, there are 10 winners, right? There are 10 winners. They are not going to lose anything, right? You're gonna win. So the remaining they are losers, right? So you're gonna be 990. We are okay with this? How many are they gonna? Okay, what is the first price? What is the smallest price? Let's go with this. Not 100, no. This is the trick. How much can you win? No, the smallest. What is it? No, if you don't win anything, you're losing because you paid $4. If you get the first prize, which is $100, how much did you win? 96. You didn't win $100. You paid 4 upfront, right? So you won only $96. How many of them? 8. What's the following price? 500, right? So how much could you win? 496. Very good. 496 because you paid $4 to get access to the 500, right? And there is only one of them. And the last price, 996. Excellent. One price here. And this is your probability distribution table, guys. Frequency distribution table, better. You know what you do with this, right? Yeah. Plug it in the calculator, please, and find the answer, please. So we get the expected value minus 1.7, right? Are we clear with this problem? Please use your calculator again. Please use the calculator. Okay, thank you for bringing this to my attention. So they are saying here, the expected person buy 5 tickets, right? So 5 tickets you will have to multiply this amount times 5. 5 times minus 1.7, right? Okay, and that's going to be minus 8.5. So that's the expectation. Each ticket you are expected to lose $1.7. All right. Now let's go to this one. So 48, you have a bag having 300 grape flavor, 400 cherry flavor, and 500 lemon flavor. In total, how many candies there or flavored ball there? 1200. Very good. So that's in total. My belief, this is there is a mistake here. So what they are supposed to tell you the first one is grape in order to get the answer correct. The first one, if I assume the first one is grape, the second one is cherry, and the third one is lemon, this would be how many grapes do you have? 300 divided by 1200. That's the grape. And then the second one would be cherry, which is 400 divided by 1200. That's cherry. And the last one is going to be lemon, which is 500 over 1200 for lemon, right? So you plug this into the calculator and you find the probability, right? I don't know what the answer is going to be. 0.03 something, 347. Is it? All right. So again, I think there is a mistake here, right? Because I did not answer to the question that they posed there. All right. So for the Tennessee question number 25, right? We did it, I think, a couple of times here we did it a couple of times, this question. So please pay attention. The way we did this, we did it as in Google, for example, right? So Google, how many words can you make out of this sentence, right? So if I had these numbers are different, like G1, for example, G2 here, O1, O2. So every letter is different right now, right? And the number of arrangement that I can do is going to be how many letters? 6 factorial, right? That's how many. If they were all of them different. So for instance, here, if I take away the 2 here and the 1 and the 2 between the O's, so what's going to happen? I can switch between them, right? I can switch this one into this and this one into this, right? And the word Google is still pronounced Google, right? It does not change at all, right? Although I switch them around, still Google. So what does mean? That the number of words is going to be divided by 2 factorial, because this is going to happen in every single word, right? So what you're going to do, you're going to divide by the number of repetition, 2 factorial here. for the O's. Is there any other repetition, guys? Oh, the O's, this is G here, right? So sorry, I mistakenly thought that is O, but this is, I meant this too, right? Let me write this. Okay, I meant for the permutation here, O and O, this one and this one. For the G's as well, I have a permutation, G and G, all right? So if you switch them around, G1 and G2, still Google, right? So that's, you have to divide by 2 factorial again. Is there any other repetition in there? No. So that's all what you need to do, right? So 6 factorial divided by 2 factorial and 2 factorial, whatever number you're going to give you. Obviously here, I wanted to use the calculator, all right? So this is going to be 6 times 5 times 4 times 3 times 2 times 1. And here you're going to be 2 times 1, 2 times 1. So you can solve this 2 here. The 2 and 6 is going to be 3. So 3 times 5 times 4 is going to be 60. Oh, yeah. I forget the 3, so 180. Is it 180? Plug it in the calculator, please, and figure out if it's 180 or not. Good. Thank you. So now, if I move on to 25, 25 is doing exactly the same thing. All right, they are doing exactly the same thing, but they are using Tennessee instead. So for Tennessee, how many letters do you have there? 9, very good. So you're going to be 9 factorial on the numerator. And then do you have any repetition? Yes. The E is repeated 1, 2, 3, 4 times, right? So you're going to divide by 4 factorial. Any other repetition? The N is repeating twice. So you're going to divide by 2 factorial. And we have as well, the S is repeating twice. So you're going to divide by another 2 factorial. Simple. And that's what you're going to give you. Okay, let me know. If you are using the calculator, maybe you want to use the parentheses on the denominator here, right? $3,780. Thank you. So that's the number that you're looking for, right? We clear about this, guys? Formula, the general formula. What is the general formula here? The total number of n factorial divided by the number of repetitions. So if I have n1 repetition, n1 factorial, n2 factorial, and keep going, right? Until you finish all the repetitions. Okay, that's 25. 26 right now. So you have 12 members, and you want to select a chairperson, secretary, and the treasurer, right? So the question is it the order important or not important? What do you think? Is it important who's going to be selected chairperson, and then who's going to be secretary? Or it's not important. It means they can switch between each other. Can they? No, obviously not. The chairperson doesn't want to give his salary to the secretary, right? The secretary wants to have the salary of the chairperson, but the chairperson doesn't want to. So you cannot switch them around, right? So the order is important. If the order is important, permutation versus Combination. Permutation, very good. Order important. This is gonna imply permutation, 12, 3. And again, you wanna plug it into the calculator. But anyways, 12, 3, what does mean if it is permutation? Basically, 12 times 11 times 10, right? It's 1320. So permutation is like you have the first one selection, 12 selections. The second one you have 11 choices. The third one you're going to do 10 choices. We are not dividing by any permutation. All right. Okay, that was 26. What about 27? In a contest in which 9 contestants are entered, in how many ways can the 5 distinct prizes be awarded? Okay, we are selecting obviously 5 out of 9, right? We are okay with this? But the question is again, is it the order important or not? If the prices were the same, is the order important or not? If the prices were the same, the order would not be important. Not important, and it would be combination. Here the prices they are saying you are distinct prices, right? So distinct prices means it does matter who's first, who's second, who's third, right? So the order important for 27. Order is important. And you remember with order important what we use? Permutation, right? So that's going to be permutation 9 and 5. We good? And what's it going to be this one? Anybody did it? $15,120, right? Thank you. All right, so for 51, 52, you're gonna be using 2 formulas in here, right? So the first formula is gonna allow you to find the missing probability, which is probability of all right, the missing probability is the probability of E intersect F. That's what we are missing, right? So this formula is the addition formula, right? So what is the formula? It's probability of E plus probability of F is going to be equal to the probability of E and F plus probability of E union F. Are we okay? So here we have almost all the probability except one of them. So the E is 0.4, the F is 0.6. E and F I don't know, so it's going to be F. And E union F, we have it is 0.8. Or 0.4 plus 0.6 is going to be 1. And here I have 0.8. So what I'm missing to make it a 1? 0.2, right? So that's the missing probability, 0.2. Are we okay with the intersection, right? Now, the second formula that we're gonna be using, so we're still doing 51, right? Maybe, maybe not. I think they're gonna give you formulas, but I wouldn't count on them, you know? Okay, so let's see. For the second formula is the conditional formula, right? Conditional probability formula. So the probability of A given B, this is going to be the probability of A and B divided by probability of B. That's the formula, right? So if I apply it right now, if I apply it in the probability of E given F, what's it going to be? It's going to be the probability of E and F divided by probability of F, isn't it? We good? Do we have them all? What is E and F? 0.2, very good. And probability of F is 0.6, right? So this one is going to be 1/3, which is 0.33, right? Now, for this it was 51, right? So this is 51. But in order to get all the way to 51, I needed step 1 and step 2, right? Now, for 52, it's very similar. So what is the probability of F given E, right? So that's going to be probability of E and F. Probability of E and F is the same thing as probability of F and E, right? If you flip the letters, it doesn't change. Divided by which one, the bottom? Probability of E, right? Or what is probability of E? 0.4, right? 0.4 here, 0.2 here. This is going to be 1/2 or 0.5. Are we okay? Now, for 53, it's pretty much the same thing, just you have to identify the letter, the word problem, right? So here it's saying you the probability of, in a happy hilltop health home, 15% of residents play shuffleboard. So that's 15%. So the probability, I can write it down, I'm doing 53 here, right? Probability of shuffleboard for S here, you're going to be 15%, 0.15. And then they go on with 40% of the residents play poker. So that's the probability of P. Poker, which is 0.4. And then they go on and they say 15% of residents gardening or garden. So this is the probability of G, gardening, is going to be 15%. 5% right now of the residents play poker and garden. The word is and here. So what does mean and? P and G, right? And that's going to be 0.05. And finally, they're asking what's the probability that a resident play poker giving is also garden. All right. So what we are looking for the probability of P playing poker giving is garden. All right, is garden. All right. That's the same formula, the conditional probability formula. So it's going to be probability of P and G divided by probability of G, because on the bottom. All right, P and G, we have it over here, and G, we have it over here. So it's going to be 0.05 divided by 0.15, and this is going to be 1/3, which is 0.33. I hope you understand it, guys. Let me know if you have any questions. Okay, 28. You're technically selecting 5 numbers from 1 to 12. And according to you guys, you are not allowed to repeat the numbers. Repetition is not allowed, right? You say yes? Where? Google says yes? Okay, guys, you gotta play a Powerball to answer to this. Come on, stop it. I'm gonna do the 2. All right, since they did not tell us repetition allowed or not, all right, so we're gonna do both of them. So 28. The order not important, but not repetition. They are two different principles. So if you cannot repeat, what's it going to be? It's going to become a combination because the order is not important. Obviously, you're going to select from 12, you're going to select 5, and case is closed. Are we okay with this? If repetition is allowed, if you are allowed to repeat, that means you take a ball and then you see a number you noted and then you put it back and you shuffle again and you pick it up again. And that's, I think, that's how we the Powerball. That's how they do it. All right. Repetition is allowed. So if repetition is allowed, you're gonna be like 5 spots. And on the first spot, how many choices do you have? You are selecting one out of how many? $12. You're good. And the second one will be what? No, you're repeating. You can repeat. So 12, you take the number and you put it back, right? So another 12. And then another 12, another 12, another 12. However, we didn't finish. They say the order not important. What does that mean? You have to take away the order. So which one is the order? The order is, they are all the same almost, right? So it's going to be a 5 factorial. That's the order. You divide by 5 factorial. That means it doesn't, this is the order is important. The first one has 12, the second one 12, the third one 12, and so forth. You got it? No? Whenever you want to take away the order from a number of combinations or number of permutations, all right, you have to divide by the number of repetitions. And the number of repetitions, they are basically, they are the five outcomes. You can shuffle them around and you can count them differently. But they are only one because it doesn't count. All right. And how many times you can shuffle them around? They are 5 factorial. You got it? So I don't know which one is the right answer for you. Did you get C12 5? Anybody got it? So this is 792 here. What about the other one? 12, 12, 12. So I guess they did not repeat that. Which one? Yeah, but regardless of what they say on the top, they are not going to give you that on the exam, right? I'm trying to answer to the question as they pose it, all right? So that's why I make the separation here. If they didn't mention repetition or no repetition, it's not my fault, all right? I'm challenging myself. I'm recording myself. I'm challenging myself. So let me stop recording. Okay, question number 29. We have 20 boys and we have 10 girls. And we want to select 3 from each, 3 boys and 3 girls. And you see the connection here is AND, right? AND means multiplication. It means we're going to select 3 here, we're going to select 3 here, and we're going to do AND here, right? So whenever you select 3 boys and 3 girls in a play, the order is not important. It doesn't matter who's first, who's second. Who's going to play, who's not, basically, right? And that's going to be combination 23 times that the AND is multiplication, and here C10 3. Plug in the calculator, please, and figure out. Question number 30. So, question number 30 is very similar. We have how many books we have? We have 10 books. How many CDs we have? 20 CDs. How many DVDs we have? 5 DVDs. We good? How many books we want to select? We want to select 4 books. How many CDs we want to select? 2 CDs. And we want to select only 1 DVD. So the order is not important here. You're going to select them all at the same time. So you're going to be combination 10-4 times combination 22 times combination 5-1, right? You plug it in, please, on the calculator, and you figure out what it is, right? Anybody got it? 19950. That's it. 00. Okay. 35 second take. All right. The probability of this. The probability of all of them are face cards or picture cards. So it means the universal set. So what will be the universal set? Or the sample space. What's it going to be, the sample space? The sample space is select 5 cards out of how many? 52, very good. And the event here that we are calling it, whatever it is, E, the event, all picture cards, so how many is it going to select? You still select 5 out of how many? 12, very good. So this is going to give you C 52 5, and this is going to give you C 12 5. So remember, is the number of the universal set or sample space here, the number of sample space on the bottom and the number of the event on the top, right? So you're going to be C 12 5 divided by C 52 5. And you have to use the calculator. So did you get it, guys? You're going to be a decimal. Anybody? Okay, this is a reminder about the formula for the probability. The probability is, this is your event, this is the sample space, and this is the event E, right? The probability of this, of the event E, is the number in E divided by the number in the sample space. Or the sample space is all the possibilities. So you're going to be C 52 5. That's how many 5 hand cards can you get. So that's the box. All right. The circle is how many 5 cards can you choose out of 12. And that's going to be C 12 5. You got it? And according to your probability definition, the number in E, that's the circle, is C 12 5, divided by the number in the box, which is C 52 5. Does it make sense? Okay, so anybody get the answer? No? How many zeros? 4. Okay, something. It means highly unlikely that it's gonna happen, right? The probability, I hope everybody, of this event E, 2 face cards, I hope everybody understands that we're gonna divide by 52 5 again, right? The same sample space. Are we okay? So now, if you want 2 face cards exactly, what does it mean? How many face cards do you have? 12. How many you gonna select? 2. That's gonna be C 12 2, right? Did you finish dealing the hand? No, you just gave 2 cards. So in order to complete your hand of 5 cards, what you need to do more? You're gonna go to no face card. How many no face cards do you have? 40, very good. You have 40 no face cards, right? So you're gonna go to those 40 and you're gonna select how many? 3 remaining, very good. So that's gonna be C 43. And you multiply them. So this is gonna be C. So this is the event E, right? This is the number of event E. So you're gonna be C 12 2 times C 43. Again, plug it in the calculator, please. All right, turn it into decimal, and then if you want to make it a fraction, click on the fraction option on the calculator. So this is 36, right? This is gonna be 37. It's gonna be exactly the same thing. Probability of the event E. What's it gonna be on the bottom? Guys, come on, please pay attention. What's it gonna be on the bottom? Same thing, C52 5, right? Now we want exactly how many red? We want 3 red, right? How many red do you have? Red card, we are 26. You're gonna select 3 of them, right? So that's gonna be C 26 3, right? Can you select from the other reds? The remaining reds? No, right? You have to go to the black right now and select the remaining cards, right? How many black cards do you have? 26. How many are you gonna select? 2. Very good. So this is gonna be C 26 2. And that's what the event E here, right? So you're gonna be C 26 3 times C 26 2. And again, you put it in the calculator, you get a decimal number. If you want to turn it into fraction, use the fraction option. Are we okay, guys, with this? Yes, please take my